in the notes, in the description below the like button, we have this following formula. However, we can't use it to solve this problem. The reason why we can't use it to solve this problem is for this main reason. Notice how it says the midpoint voltage of our inverter is 1.55 volts and our VD is 2.5 volts. If we were to take our VDD and divide it by 2 and we got 1.55 volts, we could use this very simple formula. Now, again, that's when these two are equal to each other, or VTN is about equal to VTP. Now, we can see that that's not true, right? It's not that simple. Actually, if VTN is equal to VTP, it's even simpler. It's just equal to 1. And since it's equal to 1, we would just be able to solve for it like this. Now, because this is not equal, we're not going to be using this simple formula. So we're not using this. I just want to demonstrate a case where you could use it. So instead, we are going to take all of this out and we're going to use a different equation. But it's on the same page in the notes, so it's very easy to find, but we'll demonstrate it here. What we are after is going to be the square root of our beta n over our beta p, so we're still using betas, and it's equal to our VDD minus our VM minus the absolute value of our VTP. And this is all divided by our VM minus VTN. So with this equation, I'm going to plug in the values that I have, and this is going to give us a 2.5 minus 1.55 minus the absolute value of negative 0.5. So that's again for the values that we have. It's going to be divided by our 1.55 minus 0.5. And this is going to give us an approximate value of 0.4286. So this is going to be the square root of our BN BP. Now, from the same set of notes, if you scroll up just a little bit, I believe that was on page like somewhere around 89. If you scroll up to about page 86, the start of this chapter, we are going to find out that our beta n is equal to Kn with our being multiplied by W over Ln, and beta p is equal to Kp times W over Lp. Now, what we want to find for this problem is this W over Lp. That is the important part. So that is going to be part of this. What we can do is square both sides to get rid of the square root. And if we do that, we will just come down here. So we'll say this is step 1. This is like step 1.5 to know, and this is going to be step 2 down here. So we're squaring both sides. We're going to get beta n over beta p is equal to, we are going to have a 0.184 approximately. And now we can bring our beta p by itself. Our beta n, remember, it's going to be all of this right here. We're going to have our k prime n being multiplied by our WL of n, and this is going to be divided by our 0.184, and this is equal to beta p. And I'm sorry, well, it is equal to beta p, but we only want to find the WL of p. So instead of writing beta p, we're going to write W over Lp, and we're going to divide both sides by this Kp. So K prime p is going to be on the bottom. Now all we're going to do from here is plug in our values. So we have 150 times 10 to the negative 6, and that's because it's in micro. So 150 times 10 to the negative 6. We have our WL of n, which is 1.6 for this. And it's all going to be divided by our 0.184 times our K prime P, which is just going to be 60, and then multiply by 10 to the negative 6. So once we plug all this into a calculator, once we do all of that, our answer for this problem with these variables is going to be approximately 21.78. And that's how we go about solving for this problem.